Imagine a car driving itself, swerving at just the right angle to avoid hitting a wall, all without a single line of code telling it how. How does it know what to do? The answer is an artificial brain, called a neural network. In this case, the network controls a self-driving car. The smallest unit is a perceptron, which holds a number. Perceptrons form the input, hidden, and output layers, with every perceptron in one layer connected to all the perceptrons in the next. Here, the input layer takes three values, distances to the nearest wall at different angles. The hidden layer processes them, and the output layer, a single perceptron, returns the angle the car should turn at. The interesting part is that the car isn't explicitly programmed with the math for these angles. Instead, it learns with an algorithm called gradient descent. Here's how inputs move through the network. Each connection has a weight. An input is multiplied by its weight, added together with other inputs, and then combined with a bias. This sum goes through an activation function, and the result is passed to the next layer. By the time we reach the output layer, the network produces a final turning angle. These outputs depend entirely on the weights and biases, but how are those determined? That's where gradient descent comes in. At first, the weights and biases are random. The network looks at a dataset of inputs and their correct outputs, makes a prediction, and compares it to the real answer. The difference, called loss, is squared to measure the error. Gradient descent then calculates how much to adjust each weight and bias by computing a gradient, with information on how to adjust them. The network updates its values step by step, reducing loss each time. This process repeats until the network can handle new inputs and produce angles with minimal error. Essentially, a car that drives itself with learned intelligence.